Hello and welcome to Brick Tip 55 design video. If you enjoy seeing our videos about designing with Lego, please consider supporting us on Patreon. So I'm going to go through, as always, taking this build apart so you can see all of the internal structure and see how I designed it. But before I get into that and breaking everything down, I wanted to talk about how you can modify this drawbridge design for your own cities. In particular, if you're using road plates or designing another style brick-built road or something like that. So this one is purpose-built for my brick-built roads, and you could use this same idea for your road plates. Obviously, all you'd have to do is take the curbs out, make the bridge wider and longer so a road plate will fit on either side. So what you could do instead of using the brick hinges is using either bars and clips or this style of hinge with the finger joints right on top of the box mechanism rather than building out a flat surface, and it will make the build much easier. So this is our overhanging ramp. It's very simple construction. It's the same as the original roadway if you want to look at how that works. The only difference here was that I ended the construction early with the stud on the side bricks and put a just standard brick in place. This was because I wanted to leave a space for when the roadway hinges up that it doesn't catch on the two plates, so I left a little gap in there. So I made this road double width, as I like to do, so I can add a lot of detail, like if you want to put stop lines in here. But also it serves as a functional purpose because as we get in further, you're going to see how this roadway is actually anchored. And the tongue is brick built out from the bottom of our anchor here. This is the main connector for our tongue, and it is held very sturdy in place. It is not going to move anywhere, as you can see. So if we lift our box up, you can see that there are bricks that go straight down right into our box, and that is happening on both sides. So this is absolutely anchored. Those bricks, I can't pull them out at all. They are completely locked in place, which is how I got this bridge to be so sturdy, that there was nothing going to be pulling up this side of the bridge. So to get this part out further, I made it so that one side was slightly removable, and that side is what is holding these bricks in place. So we get off the top, you can start to see the mechanisms, and these gears on either side are powering the push out. So as you turn that axle, it acts on that straight gear and pushes it out. So what happens is when this is connected to our bridge section, it has no choice but to move up because it's locked in place, and that creates the swinging motion that brings our bridge up. Okay, now we're gonna get these blocks out, and you'll see it's an actual really simple construction, but it turned out to be incredibly effective at holding it down. So we'll pull those out, and all it is two bricks with studs on the side connected to our 2x6s. And I made sure to enclose that area entirely so there was absolutely no room for the bricks to move back and forth and possibly cause some instability. So I have the axle in on both sides, connected in the middle, and again you can see that as we turn our handle, both mechanisms are engaged simultaneously. So I removed a lot of the filler bricks so you get a better idea of what is going on. First, you'll notice at the end of this Technic brick there's a pin, so that as we roll out the mechanism, it stops. If I didn't put that pin in there, it would continue rolling out until it actually fell out. And if you notice on the end of our push out here, there's a couple of plates with just one stud each instead of having a smooth surface. And the reason for that is the same as the pin in the back. As if we have our blocking brick here and we are pulling in our mechanism, those studs will jam up against the blocking brick. That keeps our attachment point from pulling out. And here's the push out all by itself. It's very simple construction with 3 Technic bricks linked together. Our straight grooved gear and our 2 sliders, and then just a bunch of tiles on top to lock everything together. Finally, we have our bent lift arm locked in with a smooth beige triple pin, and then lastly our attachment point, which is locked in with a smooth gray frictionless pin. So I did leave a bit of an overhang here, and that was to leave room for our bent lift arm to rotate back and forth. If we didn't do that, it would jam up against the very bottom of the base. And we have our slider bricks, and then the bed where the push out is going to be moving in and out. We have some tiles to fill that in. So the rollout for this bridge is about 30 degrees. If you want to have a more pitched rollout, all you'd need to do is extend how far your push out goes. If you're building this on a road section and you're using the entire road plate to do it, then you would get a much more pitched angle. And again, you can adjust that by deciding how long your flat gears are going to go and how long your rollout is going to be. So that's the basic construction. The rest of this is just filler to hold everything in place and make it nice and secure. So hopefully you found this useful and you can use this mechanism in some of your own creations. I know somebody had mentioned that they were going to use this as the thruster shield on an aircraft carrier, which is a great use for it. So thanks so much for watching. If you have liked this video, please like and subscribe and share it around so others can learn from it. Thanks so much. Have a fantastic day. Keep dreaming in bricks. Bye bye.